Have you ever worked with a data set that has some missing values or extreme numbers that makes no sense? So what do you do in such cases? Do you ignore them, delete it off, or just fill up something? So here in this video you will get an idea on what to do with such missing values and how to clean and do a data transformation. Hi, I'm Dr. Kavya Shabu, founder of Research Dreams, where we aim to provide research assistance and consultation along with career guidance. Missing data is when some of the values in a data set is left blank, unavailable, or is unknown. This can happen due to several reasons. Some of it is like the survey participants skipping some questions, or sensor errors in the Internet of Things or in the scientific experiment, data entry mistakes that has happened while manually recording it, and also loss of data due to file transfer or any technical errors. Missing data are of three types. The first one, missing completely at random. As the word suggests itself, it does not have any particular pattern and is being lost at a whole. For example, due to power outage, some data being gone missing. The second one is missing at random. This data is gone missing because a certain person cannot answer such questions. For example, children are unable to answer some questions that is being asked. The next one is missing not at random. What we mean here is the data has been not disclosed or the respondents are not willing to provide some informations for those particular fields. For example, salary. Some respondents might not wish to disclose their salary. We have two major methods available to handle missing data, which is the deletion method and the imputation method. Under deletion method, we can either delete the entire row if we find that all of the values are not coming properly, or we have too much of missing values and it's found to be insignificant for our study. We can delete off the entire row. The other one is the pairwise deletion, wherein only the missing values whichever comes, those columns are completely selected and deleted off, and only the pairwise selection of those data which is available is taken further for the study. The next one is on imputation method. Imputation method again has four steps within, which or four methods within, from which we can choose. The first one is the mean median mode imputation. That is, for the missing value, we can either find the mean, the median, or the mode value of the entire data in that particular fields, and then fill in the missing value. Under the missing values, we can fill in that value. The second one is forward or backward fill. This means the value that is coming up front or the one that has come preceded can be taken forward, pulled back or pulled down into the missing fields. The next one is KNN imputation. KNN imputation is using the nearest data point to estimate the missing value. Now this is done in such a manner that if a graph is being formed, the pattern is kept intact, and within that where the value falls into, the such values are picked out. The next one is regression imputation. Now if there is a cause and effect relationship over here between the variables, then without affecting it, how the value can be rightly calculated is found over here, and the regression value is imputed towards the missing field. What is an outlier and why does it matter? An outlier is a data point that is very different from the rest of the values. It could be very much high or very lower than the other values, which makes it stand out. For example, in a class of 100 students, suppose the average marks of the students comes around 50%, but one student alone has secured 100%. Another example is in sales. Suppose there was a major sales drop down in one particular day as compared to the other days. So such outliers are to be identified, understood, and whether to be eliminated or not, or whether to be treated. The major reason for this is so that we will have a better model example that will be statistically can be proven to be a stronger one. We can reduce the skewness of these statistics also, that is the mean and standard deviation, and also to identify genuine rare events beyond these outliers. Now let's learn how to detect these outliers and how to handle this. There are three major methods to detect the outliers that has happened. The first method is the Z-score method, within which we will see if there is any value plus or minus 3, the standard deviation. This will be treated as an outlier. The next method is the IQR method, which is also known as the interquartile range method, and in here we will be taking all the values that comes 1.5 times above the above the Q3 as outlier, and also 1.5 times below the value of Q1 as an outlier. The next method is the box plot method, wherein this is the image of a box plot, and from here any value that comes beyond its whisker is treated as an outlier. Next is on the handling methods. We have four major handling methods. The first one is trimming, that is removing of extreme values, and this is applicable and very good for smaller data sets. The next one is winsorizing. Here we will replace the extreme values with the threshold that is already being predefined. The next is the log or transformation method. This is compressing of large values using the log tables, and this will help in reducing the skewness of the data. The next method, or the fourth one, is the capping or flooring. As the name itself suggests, a cap and floor values, that is the minimum and maximum values, will be set, within which only those values will be considered for data analysis, thus removing of the outliers. Now, what we have to make sure is that not all outliers are to be removed, because some will be providing valuable insights and we have to analyze it, because before deleting them we have to understand what is the particular cause of these. What is data transformation and why do we need it? Even after data cleaning, we might require to modify and also restructure it in order to improve the analysis. Data transformation helps to ensure that the data set is in the best possible format for statistical models and machine learning algorithms. Some of the methods of data transformation are: first one, normalization and standardization. This is adjusting the numbers to a common scale. For example, changing the test score from 0 to 100 into a scale of 0 to 1 in order to compare fairly. And also standardization, which is making a same format within the field. That is, for example, we had mentioned before in the earlier video, like if we have Delhi, New Delhi, DL marked all over the document or the data set, we have to modify it all together in one particular format so that it is recognized as one unit. The next one is mathematical transformation. This is modifying values to reduce large differences. For example, using of log transformation in order to reduce or compress the values for an easier calculation. The next one is encoding categorical data. This is converting the text labels into numbers. For example, labels of male and female change to 1 and 2. This helps us in analysis where we have to do a comparative analysis or where we have to use a male and female data for analysis. The next one is on feature engineering and binning. This is a common process that we use to convert discrete data to continuous. This helps us to get more insight into class intervals. For example, we took age from the people as an open-ended question and they have all entered their age in different numbers. So if we classify it like 18 to 25, 26 to 30 as each category, it helps us to understand as to how each category is performing with regard to this data. With that, we have come to the end of our session. If you know any more additional data cleaning, do suggest in the comment section below. If you are looking for a research consultation with me, mail me in this mail ID. And also check out my website to know more about the other services provided by us.